All right, so here we want to find the velocity when t equals 0. We want to note when the particle stops moving. And we want to, let's see, what is the position at time 16? And then finally, what is the total distance traveled for the particle? So again, this is its displacement right there. Let's pick a better color. Its displacement function right there. And again, this thing is just moving along a line. So it's stuck on a straight line and it's just moving along that line. So let's get my little flashy thing here. The flashy thing work today. Oh, come on. There it goes. Yeah, so just moving along this line. And we just want to figure out how it moves. Now, note when it does that, right, it goes in a positive direction for a while, and then it turns and starts going the other way. All right, so let's consider its velocity function. So that would be 3 times 2 is 6t squared, and 2 times 24 would be negative 48t, and then plus 90. So that's the velocity function. And we want to know, when does it change direction? So we know if the velocity is greater than 0, then it's moving away. And if the velocity is less than 0, then it's moving toward whatever observation point we have, say moving backwards. And then in between, at 0, that's the turning point between moving away and it starts coming back, or when it's coming back, it turns and starts moving away. So if we can just identify those turning points, then we can then check the displacement in between those right there. So we got to solve this, set it equal to 0. Let's see, does 6 go into everything here? I think it does. 6 goes into 6 once. That's going to give us a t squared. 6 goes into 48 8 times, and 6 goes into 90. How many times? Let's see. 15 times, is that right? I think so. Yep. And does that factor? It looks like it factors as 3 times 5. And since the 8's negative and the 15's positive, these both have to be negative. So it looks like we get t equals 3. As one place, it's going to change direction. And then t equals 5 will then be the other place it changes direction. So here it says the particle stops moving. And it's an instant, it's not really a stop, it's like an instantaneous changing of direction is kind of what happens there. It's neither moving away nor moving back. And so those are the numbers we want right there, 3 and 5. And let's just check out the graph of this thing, confirm that. Favorite graph for today. Although sometimes I like GeoGebra. Have you guys ever tried GeoGebra? It's a wicked cool graphing program. Desmos has been trying to be GeoGebra since it came out. And they're constantly competing for new customers and new features. All right, so my original function, let's see, what was that? It was 2 negative 24 90. 2x cubed is 24x squared plus 90x. Got that right? 2 minuses, and that's not a cube. Oh, interesting. Raised to a third. All right, let's see, do I have it now? Minus 24 plus 90. All right, that looks better. And so then we just need to take a look at where this is. Oh, I put a t in there. Thank you, that's what you're talking there. All right. And let's see, up to 16. So we're concerned about the point 16, comma, s of 16, s of 16. is S of 60. 3,488. So I got to change the scale a bit to see that. So use the monkey wrench to change the scale. Let's go up to 5,000, and then we only need to see up to like 20 is probably good enough. All right, so here is my function. And what were the points of interest again? X equals 3 right there. And then X equals 5 for the points of interest. So here and here, what is going on there? It looks like it must dip a little in between. We have to zoom in to see that. So we go from 0 to maybe 100 instead. We should be able to confirm that. Oops, 0, 5. Did I misread that? Okay, maybe it was 0 to 200. Yeah, so we can see it wiggles in between. So we have the total displacement up to that point, and we can just get the y value 108. And then it moves from 108 to 100. And then it moves from 100 up for mine 3,488. So I'm just going to put that in a table to make a little more sense of it. So T versus its displacement S. At 0, we start at 0. And then at 3, we end up at, was it 108? Or, yeah, 108. And then down to 100. And then it changes direction to go back to 100. And then it moves straight from there over to 3,488. Is that right? For my version? Yep. $3,488. So then its total distance is going to be, it traveled that 108 right there. And then it traveled back 8, and we're not going to call it a negative there because that's part of the distance it traveled. And then it went from 100 to 3,488. And so that would be 3,388 for its total distance covered. So the sum of those would be my total distance. Yeah, and again, this is something important. Remember what the particle is doing here? The particle is just moving along the line. So from 0, it goes over to 108, then it backs up to 100, and then it takes off again to 3,488. The picture we have here, it's not on that curve. That curve is just telling us over time what its positions are, right? So that's not, the curve does not just show its movement. The movement is on a line, which is kind of a weird thing. That's what we got. Finding the distance along a curve is a whole nother thing, and we will work on that in Calc 2. All right, so for my version, it would be the sum of 108 plus 8 plus 3,388, whatever that adds up to. Good question.